I'm going to continue. Again, these are available online if you do fall behind at all. So our goal is for you to tell me what the heck this is made out of. We have like probably between all the classes about 16 different good suggestions of what it could be. And we're going to start off, believe it or not, by simply measuring it. And that's our first step that we're going to take care of. Here's a centimeter ruler. You don't need to draw it. But if we're going to measure accurately enough to actually definitively say what this is, there are 3 rules we need to follow. These 3 rules are rules that most kids can follow without me even prompting you. But we're going to write these 3 rules down just to make sure everybody can do it perfectly. For our purposes in here, we are always going to use centimeters. That's what we're going to measure it. It's going to give us the accuracy that we need to be able to identify this thing. We're not going to use meters. We're not going to use kilometers or inches or miles or light years. We're not going to use any of those distances or lengths. We are going to use centimeters. Centimeters are perfect. So there's something to write down. Hopefully you can tell the difference between centimeters and inches on a ruler. I think you had no issue with that when we were doing our sail car labs and stuff like that, so we shouldn't have any issues. Next, you're always going to round your answer to the nearest tenth when we're trying to identify substances. Always round it to the nearest tenth. Oh, that's right there. My friend. Cool. What's that mean? It means that you have a digit after the whole centimeter. So like 1.1 centimeters, 17.3 centimeters. It's point, a digit, and nothing more, nothing less. You got to have 1 digit past the decimal. And by the way, if you're wondering about the rounding, you just look at the next digit to figure out whether that 1 digit stays what it is or it goes up. So far, so good. Last rule to follow. Last rule is always include the unit with your answer. Okay? Okay. Are you doing okay with the writing? With your hand, or is it an issue? Uh-oh, I need another one. Give me one word. What? No.
Unicorn.
Space fabulous.
Got it. Space fabulous house of unicorns. That one was tough because we're all yelling things at the last minute. I had to. That's fine. We don't really do it. Hi. How you doing? You doing great? Good. Sure. Yes. Okay. I have no specs on this table.
Because I didn't do anything in my field.
Oh, no. I thoroughly confused that woman. She wasn't even in the school. She's like, unicorns? What? Thank you for your randomness. Actually, it was a great place to take a little breather because now you're going to have to do this for me. And now, when I ask you to do something, here's how it works. Okay? If you have your hand in the air, it means you know the answer. If you have your hand not in the air, you're also telling me something. You're telling me you do not know how to do what I'm asking you to do. So either way, you're communicating with me. You understand? If your hand's not in the air, that means I do not know how to do this. And I will continue to explain it until you do. So there's no like, I'm shy. We don't really do that, okay? So I use your hands in the air as a way to be able to do this. Sorry. Oh, you don't like that, do you? Okay. Here we go. Check it out. What I'm going to do is I'll start off. Okay, I'll only wait for half of you to have your hands in the air for the first one. That'll be good. What I'm going to do is I'm going to pop something up here. I do need you to stay silent. And I need you to follow all 3 rules and give me the measurement of that thing there. So follow all 3 rules and give me the measurement. I'm only going to wait for half the people, but the next one I'm going to wait for everyone. Okay, so hopefully it should be 1, 2, 3, 4, 5. Oh, I need some more than that. I do need more. I'm sorry. If your hand's not in the air, it means you can't do it or you can't see it. Possibly.
All 3 rules?
What? Cool. You talking to each other is going to make it go slow. So let's go ahead and make it go fast. Gibson, you think you know what it is? Go ahead.
1.3 centimeters.
Perfect. Okay, she got a little weird, like you're speaking a different language there in the middle part, but other than that, it's pretty good. 1.3 centimeters. I actually like that. Everything's perfect. It's rounded, it's correct, and it's got the unit on the end. Perfect. Now that was half of you. Let's see if we can have everybody do it this time. Ready? We got 1.123 centimeters. Everything about that is great. Now be careful. I'm going to pick up the pace. Here's another one. We're going to need some more people with their hands in the air. Okay? And wait, don't care. You don't have to. No, do care. Don't be a culture of people who don't care. Casey, what?
1.9 centimeters.
1.9 centimeters. So far, so good. Now it's all getting real up in here. Take a look at this. I don't know where that even came from. All right, so let's check this out and see what we got. Be careful. Be careful. Be careful. Be careful. Yeah, now what?
5.0
Oh, I was so excited to do my little "you're wrong" dance. You're wrong. You're wrong. Because when I call on kids, half the time I was like watching your mouth to see what you'd say. Half the time they're like a 5.0 centimeters, and then I'm like, oh, that was right. And then the other half of the time they're like 5 centimeters, and I'm like, you stink. She said 5.0. If you were gonna say 5 centimeters, you would have gotten the "you stink" dance because you didn't round to the nearest tenth. In science, when you're measuring, I'll tell you right now, 5 and 5.0 are two different numbers because they show different degrees of accuracy. So if I ask you to round to the nearest tenth, you got to make sure you do, otherwise the whole thing is wrong. Looking next like, I can't believe that just happened. All right, so check this out. Make sure that you can round to the nearest tenth. And finally, my last one, what I do need you to do is be completely silent and raise your hand. Completely silent and raise your hand. That's not a but. Nope, completely silent and raise your hand. Go for it. What?
Can't tell exactly what it is because.
No, I can't do my little dance. You were supposed to say 5.9, but that's all right. Go ahead and explain what you want to say.
Because it says at the very beginning of the ruler, not at the zero mark.
Gotcha. Yeah, all the kids are looking at 5. I can tell half of you are like, oh my gosh, I'm so glad that he didn't just call on me because I would have said 5.9 until you look right here and you realize how big of a jerk I am. Look at this. Look at this whole situation here. Okay? The whole reason why I did it was to show you one thing that kids very often do. Since you're going to have to measure super accurately in order to be able to identify this little cube right here, here's what kids do. It's like, I'm smart, so here's what I'm going to do. Okay? I'm going to take my cube and I'm going to set it on the table, and then I'm going to take my ruler and I'm going to put it like this, and I'm going to measure it like that. And then they get extra serious by closing one eye, making their measuring face. Okay, when they're doing that? Do not do this. Don't ever do this. Because if you look at the end of your ruler, very often there's a nether region. You know what I mean? Like a little nub. A ruler nubby. Yeah, there's something down here that has no measurement on it. The second you go like this, bonk, and that, it's going to make your measurement off. So make sure you do it by, holding up, making sure it's on the right mark and not pushing down the side of the ruler. Okay, so that part is relatively easy. Now you have to follow my directions exactly, so good luck. This is where last class almost missed that person getting wet. Okay, so listen carefully. What I need you to do is I'm going to need each of the pair, okay? Each of the pair of you. You guys can work you can work with your friend there, that's good. Oh, that's me. Okay, so here's what I need you to do. I want you to work with the person sitting directly next to you or work alone in your situation. And I want you to grab a cube and I want you to grab a ruler.
What, son? Yo, give me my cube, man. Give me my cube.
Okay, do not measure it. Do not say anything else about it. I'm telling you right now, I'm already over time on what I want you to do, and you're all talking about something else and doing something else. I'm just going to let you know, this year I will hand out like 100 things to you and tell you to do something with it. Look through it. Light it on fire. Listen, you need to do these things quickly, and you need to stay completely focused on me. It's not like, yeah, I got the cube, That's great. I'm real excited for you, but you're just holding the same cube, okay? Let's not be that big a deal. All right, so here's what I need from you. Ready? Listen very carefully to these instructions. I need one of the two of you to measure the length of the cube. I want the other person to not look. Go. One of the pair measure the cube. The other person does not look.
Don't tell me, don't tell me.
Okay. You talking is just going to make it go slower. I mean, it doesn't need to be silent, but we need to be productive here. Now, people who are measuring, just something for you. People who are measuring, I want you to write down what you get in your journal following these 3 rules, but cover it with your hand when you're done writing it. I'll know when you're done, when it's covered with your hand. Doesn't need to be silent, it just needs to be on task.
Are you done? Now we have
On the first little mark, yeah, you'll have to count it. And all rulers are going to be different, so it might be the end of the. So how many ones are there? That one I think you can put to the end of the ruler. Should be okay. Yeah. Go to the furthest line you have. Cool, cover it. Whatever your answer is, cover it. That's how I'll know when you're done, when you have your answer covered. Still waiting on 3 kids, that's fine, but we need to pick up the pace, otherwise she's not getting wet.
Alexis looks scared.
She should be. Alright, switch and do the same thing in your journal. Other person's not looking, okay? That took us about a minute longer than it needed to, so I need you to pick it up. I would do it from the first line that you see. That would be my guess. You can do it from the end of the ruler on that one, too. We'll be out by one. Samira, don't get bent out of shape. It's okay.
covered.
I'll know you're done when both answers are covered. These guys are done. These guys are done. What? Here's the ruler and watch. Are you still back there? Casey, done? Done. All right, this should take you no longer than a minute. As I mentioned, we're now cutting it close. Ready? You're getting some instructions. All right, here's what I need you to do. I need you to compare answers. If they're the same, then you can chat for 30 seconds. If they're not the same, then you need to make it so that you agree on the answer. Got it? So compare your 2 answers. If they are identical, great. If not, decide on what you want to do. And I usually don't get used to that.
Don't you start it where the first line is?
It depends on how many lines you have. It could be the end of your ruler.
Don't start why.
Stop me in 10 seconds. Take the cubes, put it back in, put the rulers back in. Yes, I will. Thank you. All right, back to the journal. How many of you were able to get yourself to agree within 1 millimeter? Within 1. Within 1 millimeter. 1/10. Great, so yours is easy to fix. So that's no big deal because now you know what you're doing. Great, put your hands down, listen carefully. All of these are forged from the same place. They all range from 2.4 to 2.6 centimeters. So if your range is in there, you're probably fine. What did you guys have?
3.0.
Good. You have an issue, and your issue is that you rounded to the nearest whole number, because there's no way it's 3. I'm not joking. Feel free to try to measure it with them. You will see. Now, the rest of you, as I mentioned, we're still getting further and further behind because I've had to stop a couple places with people looking at each other, talking to each other at different times. This class is completely scheduled out to the second. And every time I stop for transitions, every time I stop for you to put things in the bin, every time I have to wait for you to take them out and stop your conversation about something else, it puts us further behind. Okay, there are another 160 of these classes coming that are timed exactly like this. So again, it's not a problem, you're all being good, you just need to be more focused and you need to be faster. Otherwise, you'll miss the best part, which is happening right here. All right, do you have a hood?
Yeah.
Perfect. Okay. So that's where I got to get. I'll tell you right now, I have 11 minutes and 31 seconds left in the class period. I still have another journal entry and set that up, and I need at least 3.5 minutes to do that. So if you want this, I got to work really, really quickly. 3 of you had problems. Did you figure out yours? Did we figure out ours over here? Okay, perfect. And then the only other problem was over here measuring in inches, correct?
Yep.
So that's a problem that we probably won't have again. All right, so we're probably in good shape. Let's go to our next blank page. We got to get serious here about something because we're going to get a little bit more conceptual. I'll tell you right now, this is going to be journal entry WMT2. Great. Every single class or every single kid here was able to find that this had a measurement between 2.4 and 2.6 centimeters, roughly. That's the length of this cube, or height, or width, depending on how it is that you're holding it. That will not tell us what it's made out of. You can't be like, yay, it's 2.4 centimeters long. It must be stainless steel. It doesn't do anything for you. But it's a first step to be able to identify exactly what this is. There's more we can tell simply by measuring it. We can also find its volume. Now, if you're sitting there not paying attention, disengaged with your brain, I need you engaged now 100%. Because I need you to tell me, what is volume? Length is like a distance from here to here. That's what length is, okay? From here to here, from there to there. What is, when you're talking about volume, what are you talking about? What are you talking about? Kyle, what are you talking about?
The amount of space within a cubic.
Perfect. Like the amount of space something takes up. Its bigness, its size, how much you can hold, how much you can put in it. Okay? This has a big volume. This has a little volume. This has a tiny volume. It's the size of it. Okay? I love the word bigness, even though it's not even really a word. Okay? It's how big it is. It's not its mass. Okay? Mass has nothing to do with it.
weight.
Yeah, because if you're talking about mass, you have big helium balloon is huge, but it's like, whoa, that's easy. All right, it might have rock that's only this big, but it could be heavy. So we're talking simply about the size that it has. And I'm going to use pretty much identical to what Kyle said in our journal, for those good. It's the amount of space an object takes up. Now, since that went quickly, we can definitely do some cool stuff here. You just stay right there. Don't you worry about nothing.
Oh my god. That wasn't creepy. Okay.
Alrighty. Not only can we tell the length of something, but we can also tell its bigness, or how much space it takes up, how much it can hold. And that's going to get us one step closer. Now, in order to talk about size, in science we don't say, oh, that's teeny tiny, or that's super big, or that's medium tiny. That's not what we say. We give numbers to these things. In order to have numbers, you need to have a formula. Usually there's a kid out there that knows the formula for finding like the volume of the cube. Very often there are kids that just know this. How would you find the formula? Hey, or how would you find it? The formula for area was, do you remember, it was length times width? But that only gave you something flat. You need something else to figure out how big it is completely. Just curious, Bree, do you know?
Length times width times height.
Perfect. So if we know that, now all of a sudden we got more information to try to help us identify this cube. Not in charge of them. That's my job. It's kind of fun to watch them not write it down, to tell you the truth. So we can come up with the length, width, and height. We can multiply these things together, and we can come up with its volume, or how big it is, and actually ascribe that a number. Now, as we do this, here's where I'm going to skip, because I realize I've been really riding you guys and making you go quickly through the transitions, and I think that you are all paying attention. You're just a little excited right now, and that's fine. But just keep in mind, you need your transitions to be faster and be more focused on me. But let me change it so that we do get a chance to soak this girl, because I really want to do that at the end of the day. So let's take a look here. I'm going to change what I was doing a little bit, and why don't you draw a cube, or if you can't draw a cube, just draw a square. That's fine. And quickly, what I want you to do is, let's give a little sample of how we could find the volume of something. If this were 2.0 centimeters, yeah, great. Sorry, it doesn't look real good. So let's say that was 2.0 centimeters. Let's say that this was 2.0 centimeters. And let's say this up the side. Sorry, it's not being helpful. Journal entries really should be pretty silent for the most part. And now they're all randomly back. Perfect. In case you missed that, I wrote those like 15 times. They disappeared, and now they're back. 2.0 centimeters down here, 2.0 centimeters down here, 2.0 centimeters down here. That's all we need. Please don't comment on the fact it's ugly. We get it. So if you draw it, so that's 2.0, 2.0, 2.0, pretty much anybody I could call on in the class should be able to tell me numerically what the volume would be for length times width times height. So you do have calculators, but you should be able to do it in your head. I'm just curious. Raise your hand if you can tell me. But should have a lot of people with their hands here, otherwise it means you can't, which is more disturbing really than anything. Again, we're taking the length, the width, and the height of this and multiply them together. It's 2.0, 2.0, and 2.0. If your hand's not there, it means you don't know. That's okay. Lots of people don't know things. Great. If you are going to tell me 6, put your hand down because it's not the answer. Okay, that was easy. Got rid of a couple of you because you're like, oh, I get it. There's 3 2s, so 2 times. No, that's way wrong. All right, so what do we got? Linguists, what do we got? 8. Great, and I'm going to go ahead and round it. We're going to call it 8.0. We do need a unit on there, just curious. Now, we had centimeters when you talk about a length. That's centimeters. When you talk about an area, it's centimeters squared. But now we're 3D. We're talking about the size of something that's not one-dimensional, not two-dimensional, but three-dimensional. So what is it? I'm just curious real quick. What is it?
Small 3.
Small 3, yeah. We're going to call it CM3 or cubic centimeters. Sometimes they actually call them cc's. You ever hear that on like a doctor show or been in the emergency room? Like, give them 20 cc's of epinephrine. Actually, that would kill you. Give them 1 cc of epinephrine. 1 cc means a cubic centimeter. That's what it stands for. Now, what's kind of cool about this, we definitely need that written down, so I got it right there. What's kind of cool about this is I have a cc in front of you. I have a cubic centimeter. I have a CM3, so you can actually see one. And that's my goal for what I want to do right here. Oh, it's going to be tight. I hope we can do it. Here is a cubic centimeter. When you measure like this box and you find it to be 8 cubic centimeters, it means it would take me 8 of these little things right here to make it. If I measure the volume of you and I find it to be, 20,000 cc's, it means it would take me 20,000 of these cubes to build something that would take up the same amount of space. So we shouldn't have any issues with that. Let me show you something super cool. Check this out. Okay, don't worry, I'll give you a heads up. Now, 100% on me for the next 2 minutes and we can do it. Otherwise, I just scrap it right at the end. So check it out. Check this thing out. It's a cube. I love this cube. I don't know why, okay? But it holds the little other cube perfectly right in the corner. Can you see it down there? I stuck it right down there in the corner. The little cube got it right there. Well, I got a whole bunch of these cubes. And one day I started putting them in. I was like, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I found I could get 10 across the bottom. Exactly. And I also found I could get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up the side. Exactly. So I'd have 10 by 10. And there's exactly 10 going back like this. So if this is 10 by 10 by 10, how many of these cubes could I get in there? If it's 10 by 10 by 10, you do have a calculator. You might need it for that one, possibly. 10 by 10 by 10. How many could I get in there? 10 going this way. 10 rows of 10. But then 10 of those rows. If you're going to say 100, put your hands down, because that's wrong. Mike, what you thinking?
1,000.
I can get 1,000 of these. I actually did it. It took me about an hour and 20 minutes. It seems like it'd be really easy, but I have all these cubes. They're all different colors. And I was like, 1, 2, and then I was like, yay! And then I'm like, now what? That wasn't really that much fun. But I got 1,000 cubes in there. I got 10 by 10, which is 100, and then I got 10 rows of 100. So it's like 100, 200, 300, 400, 500, 600, 700, and then 1,000, which is 1,000. Okay, so great. This is the coolest part of this whole thing. This is 1,000 cubic centimeters. Now watch, very, very carefully. A cubic centimeter is the exact same thing as a milliliter. You ever heard of a milliliter before? I bet you were measuring in milliliters probably last year. Using something called a graduated cylinder. Like this right here is a graduated cylinder, so free to take a peek at it. Okay, if you're going to make noise, I can't do it right now. I'm just telling you right now, 42 seconds. That's how much time I have to do this right now. Okay? This right here is a milliliter. So in other words, if this were a little tiny cup and I poured it in here over and over and over again, I would have to pour it in 1,000 times to get it to be 1,000 milliliters. Which means that this and this must be the exact same size, 1,000 milliliters and 1,000 cubic centimeters. Doesn't it not look it?
Yeah.
Because I was looking at it and I was like, there's no way. No way that's possible. All right. So then I decided it would be cool if I did this right next to you. Ready? Put your hood on. So I'm going to close my eyes. No matter what happens, I'm going to keep pouring. Here we go. Ready? Oh, cool. Good thing. They are the same thing. Hey, take it easy. Have a good one. Put your journals. Put them back in the bin. Have a good one. Split them vocab 3 and 4 to Friday. Go home. What period is it? What period is it? Put your chairs up. Have a good one. What I think you